Wonderful. Okay. Yeah. Hi, folks. Thanks for joining us. If you're here for our event with Heino Falcke and Kate Greene, you are in the right place. We'll get started in just a moment. So you know, this is for Heino's book, Light in the Darkness, Black Holes, the Universe, and Us. We're very excited to have him here with us today, along with Kate. So while you folks are taking your seats, I'd like to go ahead and just say a brief hello, welcome. I'm Car. I'm the events coordinator for Green Apple Books here in San Francisco, California. Beautiful San Francisco, California. I'm really pleased that you folks can join us today. I wanted to tell you about a couple of events that we have coming up before we get to the topic of the hour. First, on Tuesday, June 29th at 6 p.m. Pacific time, Rivka Galchin is going to be joined by Paul Lafarge to discuss her latest novel, Everyone Knows Your Mother is a Witch. Galchin is a genius. Lafarge is a genius. We're very excited to have them here. This will be a virtual event, so you can tune in and find that login on our website. Again, that's on Tuesday, June 29th at 6 p.m. Pacific time. We do have an entire event calendar on our website at greenapplebooks.com. All of our events are free unless stated otherwise. That being said, I'm not above it. Please do buy books if you can. Please do buy the books of the authors who are joining us today, if you can. When you buy books from an independent bookstore, not only does it help us put on events like this, it also supports the authors who put so much work into making these books, and then you get to have and read their books, which might be the best part. So if you can, please do buy books. I will also encourage you to, during the hour, enter your questions into the Q&A box that we have set up on the bottom of your screen here. It might be at the top of your screen, depending on your interface, but it will say Q&A. And while we're here too, I would encourage you to just say hello in the chat. Let us know where you're tuning in from. We love to see where folks are joining us from. So without further ado, I'd like to go ahead and introduce the two authors joining us this evening. Kate Greene is a writer and former laser physicist whose poetry and prose have appeared in Ion, The Atlantic, Discover, The Economist, Harvard Review, The New Yorker, and others. Her essays have been featured on NPR's All Things Considered and Wait, Wait, Don't Tell Me, CBS News Radio, and the BBC World Service. She is taught writing at Vanderbilt University, San Francisco State University, the Tennessee Prison for Women, and at Columbia University as a teaching fellow. In 2013, Greene was the crew writer and second in command on a 4-month simulated Mars mission for the NASA-funded High Seas project. Her memoir and essays based on the experience, Once Upon a Time I Lived on Mars, was published from St. Martin's last year in 2020, and we had the pleasure of hosting her for that then. Please do welcome back Kate Greene. And last but most certainly not least, Heino Falcke is a highly decorated astrophysicist at Radboud University in the Netherlands. In 2021, he received the Henry Draper Medal of the US National Academy of Sciences for his idea of capturing an image of the black hole. This breakthrough was achieved by the International Event Horizon Telescope project, in which he held a leading role. You can also find him in the documentary Black Holes, The Edge of All We Know on Netflix. His book, I'll show you once again, Light in the Darkness, Black Holes, the Universe, and Us, is the reason we're here today. So please join me in welcoming Heino Falcke. Thanks, you two.
Thank you.
Thanks, Car. Thanks so much. Heino, this book is gorgeous. I just wanted to thank you personally for putting together such an unusual science book. And I mean, it's a science book that's brimming with humanity as well as information, and somehow to compassion. And it's just so unusual to find all of these elements kind of combining together to create something that's larger than the sum of its parts. And it's broken up into 4 sections, which is just, I felt at such ease with the storytelling. I'm in New York, so there might be a little bit of background noise, all you out there. But in particular, the way that you started with like setting a scene at the press conference, but then kind of zooming out into like the larger cosmos as we go, and then bringing it all together, answering the question of what it all means. And in particular, you you speak a lot, no, I wouldn't say a lot, but you mention your faith in a way that feels like just incredibly appropriate because of the way it undergirds your mission as a scientist. And I appreciated the candor there and the perspective that it brought. And so I just wanted to start this off by reading from page 6 of your book. This was, I'm reading along, I'm wondering what kind of book is this going to be, and the early pages are always something that does that for a reader, tells them how to read the book. And I came to this paragraph after a discussion on, astronauts in orbit. They take so many pictures of Earth, and every time you see, well, I'll just start reading it. Every time I see these beautiful images of Earth, I also sense the loneliness and emptiness, the pain and suffering that are felt all over the world. Quote, he spreads out the northern skies over empty space. He suspends the earth over nothing. So cried sorrow-stricken Job millennia ago. The nothingness of heaven spread out like a black canvas, and in the middle, our planet Earth. The biblical writer was not granted this view from above, and yet in his visions, he already perceived the Earth as a whole. And then just on the next page, you're talking about time being relative, and you quote a famous old psalm, 1,000 years in your sight are like a day that has just gone by. And these two quotes in particular, it's the first time like another text is brought into your text. And for me, it was just such a wonderful perspective giving moment as a reader to know that, oh, this book isn't just about science. This book is deep, this book is broad, and this is going to be a joy to read. So I just wanted to kind of kick it off with that and thank you for that perspective. Now, I wondered if you could, the whole reason this book exists is because of black holes and because of that picture of a black hole. And I wondered if you could, well, actually, why don't we just start with, tell me about how you came to know about black holes and what about them captured your imagination?
Well, when I was a kid, I always, asked questions, and I was going to the fundamental questions. What is, why, and why is this, and why? And so, when I was, growing up, I wanted to do something, addressing fundamental questions. So, either theology or particle physics. And then I realized that astrophysics was just starting to bloom. And it was a universe out there that I didn't know, with so many mysteries and secrets. And one of the biggest secrets, at the time were these black holes that didn't really exist yet. They were theories and ideas and mythological objects almost. It was clear that at the edge of black holes, the future of physics would be decided in a way, because the big unification of all the forces, gravity and all the other forces of quantum physics has to happen at the edge of black holes. But do they exist? Are they there? And so, in the 90s, the first clear indications came that, in the dark hearts of galaxies, there is something that is very heavy, very mysterious. And so I was starting my PhD, and so these first measurements came out about the center of the Milky Way that later got a Nobel Prize, actually, last year. And I completely switched what I did, and I jumped on this, and I stuck with it for the next 20 years. I wanted to see that thing. I wanted to find out what's in there, and do they exist? What's in the hearts of these galaxies. And that was a journey of 25 years. And in the end, we saw it. That's an amazing, experience that you don't have often in science. You start with something that is, far away. It's just theory, and it's big. It's big. And then you're one of the first people on the planet to actually be able to see it with your eyes.
Yeah, what an absolute trip. Your book reminded me that in the 90s, when I came to know about black holes and also fell in love with black holes, if you can say that about a black hole, can you actually even love a black hole?
Don't get too close, though, right? So
keep your distance. But it reminded me that in the 90s, when I was learning all about them, you write, there was really only circumstantial evidence And that's wild to me that we've gone from that understanding, you know, it was the math around it and sort of like, and data that implied that these things existed, to an actual visual representation. I mean, this is it. This is the actual black hole. I wanted to also say that this book is full of fantastic science descriptions. And in particular, you describe black holes a lot. And as someone who's been a science journalist and has had to write about black holes in a limited amount of space, I always use the phrase, you know, that from which light cannot not even light can escape. And, you know, you hear that all the time. But something that I appreciated about this book was all the different ways that a black hole is described so viscerally and just really effectively. And I wondered if you could just read a short section from page 93 that gave a nice description that I hadn't heard, and it got me very excited.
Yeah, okay. It's the first time I read that section, actually. So let's hope I do it well. So it's in Einstein's theory, the space around a black hole is like a rushing river that ends in a waterfall at the Schwarzschild radius. Light is like a swimmer in the space river. Far off from the edge, it's still able to swim against the current. Closer to the waterfall, the current grows stronger and it has to swim stronger and stronger. At some point, though, not even a world champion swimmer can escape the rushing current. The swimmer is swept away. Once you fall over the edge of the cliff, it's too late. No one can swim up a waterfall. The exact same thing happens at the Schwarzschild radius. It's a point of no return. There, not even your cries will get out. Even light, along with space, is pulled into the depth. In 1956, the physicist Wolfgang Rindler coined the term event horizon for this uncanny boundary. The event horizon can be neither touched nor felt. It's only a certain margin in empty space, a mathematical definition, and yet a dividing line.
Thank you. That's so wonderful. So I wonder if now would be a good time to sort of reveal the image. We have it on your book, but the press conference was a very big deal. Your book tells the story of it. The whole story of putting all this together was actually really harrowing. One of your students in Mexico was in danger. That was, you know, being held up by men in masks and with guns. That was really something unexpected, and just the sheer fact of, well, I guess the scale of the project, it was truly global, and you knew it from the beginning. And so you had to get global buy-in. And you worked for years and years to do that. And then to have this press conference where all of this is culminating, and like the eyes of the world are on this. So I don't know, could you set that up a little bit? Tell us a little bit.
Yeah. You described it well. I mean, it starts with an idea. At some point, you have to actually, you know, try to image a black hole. We turned the entire world into a telescope. And we needed the world to image the black hole. And then we gave it back to the world at this press conference, and the world actually embraced it, unlike I ever could imagine and expect. That was really an impressive moment. It was a global collaboration of 250 and then 300 scientists around the world, in Asia, in America, in Europe, in Latin America, Africa as well. And we saw that image in 2018, and, you know, around the summer, we had the first data, and then we had to make sure we were not fooling ourselves, right? So it was an intense year that we really struggled with the data to check whether it's correct or not. And then, we had to be very secretive. We didn't want to tell anybody because, the press was after us. They wanted to find out. People were asking us, and so any leak could have, spoiled the story and could have, set the wrong stage, actually.
Mhm.
And then, in April 2019, we had this big press conference, actually 7 places around the world. One was in Washington, in Taipei, in Tokyo, and in Santiago, in Chile. And I was in Brussels, in the big press room of the European Commission. That's where all the big states of heads are giving their press conferences and presenting that image. And it was it had to be timed to the second to release that image. And we did this showing an image, a movie. And I want to actually take you back to this press conference in April 10, 2019. It's 6 minutes after 3, 20 seconds after 6 minutes after 3. And it takes 40 seconds to reveal that image. And I was on stage and had to sort of tell the story. And it's this zoom that is the biggest zoom in astronomy that we have. We're zooming into the universe by a factor of 1 billion. We're starting in Chile, where some of our telescopes are located. We're looking up into the night sky and zooming into the constellation Virgo, where this biggest galaxy in our cosmic neighborhood, just 55 million light years away, is located. It's a giant galaxy with some weird activity that spews out plasma and gas that surrounds the entire galaxy. It all comes from this plasma stream that comes from the very heart of this galaxy. We never saw the source until we saw that. And that was the first image that was ever made of a black hole. And this actually is a more recent version that also shows the polarization of light, the way it actually, vibrates. It shows magnetic fields and stuff. But that's the image that we saw. And you see this ring of light, and that comes from the fact that light is bent around black holes. It goes in circles, really. And in the very center, you have this darkness. Typically in astronomy, all the bright objects, the small, very bright objects are bright in the center. The sun is the brightest in the center. But this one has darkness at its heart. And that is the signature of the event horizon. In fact, you can never see the event horizon or the black hole. You can only see what you do not see. You do not see light. You only see the darkness. And so we talk here of the shadow of the black hole.
That's fantastic. And this image, yeah, you mentioned that this one's a little bit different than the one that originally came out. It shows a polarization of light as well. Now, there's something, some nuance to this that I think is pretty interesting. That these aren't the actual colors of a black hole. This is what is formed from radio waves, which are not in the visible spectrum and on the electromagnetic spectrum. And so I wondered if you could talk a little bit about the fact that these are radio telescopes all over the world that you had to combine information from to create this image. And also, I was wondering, your book mentioned that this is a technique that's been around for a while, combining different radio telescope images. But I wasn't sure, was this the first time the entire Earth at that scale had been used for such an image?
No, one of the things that I realized in the 90s, actually doing my PhD, was you'd have to go to very high radio frequencies to get close to the black hole. And as you saw before in that zoom, these were also images. Many of those were images made with very much the same technology. And what you would see is just this plasma, that's shooting out of the galaxy. And you'd go to a higher frequency. If you go to a higher frequency, you get a higher resolution. You zoom further in. But we predicted that if you go to a high enough frequency, and we named a very specific frequency, you would actually start to see the black hole because you get high enough resolution. And this is the highest resolution experiment made from Earth. So there's no way, there's never before has such a high resolution image been made from the ground. In fact, there are some space experiments, but they don't have that high quality. So it really is the highest resolution image ever made, so to speak. And that was the technology breakthrough at these high frequencies. Yes, it's radio light. You're absolutely right. The colors we see are colors we don't know, as a friend of mine, a musician, once said. So we have to translate them into something that our eyes can see. And in fact, radio light is exactly like optical light. It's just that the frequency is different. Yeah? Like you have different frequencies on your car radio. You can extend that, to comparing light to radio. And it's sort of the extreme red light you can think of. But honestly, the colors we show here is an artificial choice. In fact, we made that choice in our prediction paper in 2000, and because we were thinking, what color do we give a black hole? What color is a black hole? How do we see it? And colleagues were using rainbow colors. They're very popular too these days. But I thought, a black hole is not a happy place, right? It's not the appropriate color scale. So we went for this heat. It's supposed to represent heat, a glowing iron, or stove, or fire, and yeah. And I think that captures it. We could have made it green. We could have made it pink or whatever. I suspect it would have changed the impact of that image. So science is, science, but there's an aspect of it that's also a bit art.
Absolutely. That's what I was thinking too. And like the heat aspect is so interesting. Black holes are actually very hot, aren't they? I mean, this is a furnace.
And that is, that's black holes are just extremes. By themselves, black holes are just the coldest objects in the entire universe, right? There's nothing can be cooler than black holes. They're really cool. But then they're also the hottest objects. And that's the gas surrounding it. If everything that falls towards it gets accelerated, and it reaches almost the speed of light. So, all the gas is going around like in turbulent plasma streams, and it starts to heat up. Magnetic fields are there, there's viscosity, and it's just a big car crash. It's like entire I-95, from all cars come from all directions, crashing into each other with the speed of light. It's just a big inferno that's happening near black holes outside. And but once you get inside, you have this darkness. So it's this contrast, this ring of fire that you see, and then this perfect darkness in the very center that makes it so interesting. I mean, I don't know whether you noticed that, but the music that was playing was this Zoom video. Yeah, when we're zooming in, was actually the music was from my son, who was actually making film music, and we were discussing how to what kind of music should you produce for this. And I was expecting, like, at the end, I wanted a dramatic finale as you go close to the black hole, right? And what a bang. But what he did was like, it was like going up, and then it was like it was fading away at the very end. And I thought, yes, he understood the essence of black holes much better than I did. That's how you need to represent them. It's sort of it's this big inferno, and then it disappears in the event horizon, and it's out of our view.
That's such a wonderful anecdote, and it gets into a question that I've had. That's a version of a question a friend of mine asked at one of the events here in New York that revealed the picture and talked about it. And he said, the visual is so important, and everyone thinks about the visual. And of course, in this case, since it had never been done before, it's of the utmost importance. But he also asked, what about the other senses? What else is happening around the black hole? And so the fact that you mentioned your son's music, like that interpretation of just the sort of like the suppressing of everything as you get closer is very interesting. But how else do you think of a black hole in terms of senses, in terms of sound, or even smell or taste, or what does it feel like? What would it feel like on a body?
That's a very interesting question. I think, it's in a sense a timely question, because another student of mine actually is now trying to put together an exhibition, because he said, we have never experienced black holes with other senses than with our eyes, so can we try to do something where you experience black holes, more wholesome in a way, right? So with your body, it's certainly there's compression, is one aspect of it. this sound, also the silence. Once you're inside, you are in a different world, so to speak, suddenly. So there is a transition. You go into black holes. And in fact, at the event horizon, at that cliff, not much happens yet. Like a waterfall, right? If you go over the cliff of a waterfall, it's probably, if you're not scared of death, it's probably a fun thing, at the cliff, right? And then there's free fall, and you're really freely falling into this space. But then at the very end, I'm sorry, comes this compression and the end, right? So that comes nonetheless. How does it smell? That's a good question. I don't have a smell. I've never thought about this. What would be the appropriate smell? Of course, in a real black hole, you wouldn't be able to smell, right? So because it's vacuum and you're in outer space, that's something to think about. I have no idea. So maybe some of the viewers have some ideas how black holes should smell or taste.
Or taste, exactly. So I wondered if we could read from the book again, page 242 to 243.
Oh yeah, about black holes. Okay. Gravity monsters, cosmic feeding machines, hellish abyss. No superlative is big enough to describe a black hole. Black holes are the dinosaurs of astrophysics, as popular as the Tyrannosaurus rex, despite or even precisely because of their fearful reputation. The fact that our image of the black hole adorned the covers of magazines the world over was exciting enough, but that people would respond so emotionally to it made things even more moving. People have told me how they fell under the spell of the image, how they couldn't sleep the night before it was revealed, or how deeply touched and moved they were when they saw it. Neither the Higgs boson nor the discovery of gravitational waves has triggered such an emotional outpouring. So what, then, do black holes have to tell us about ourselves? It seems to me that they represent fundamental human fears in a way that is unlike any other scientific phenomenon. They are one of the big mysteries in the broad reaches of space. In astrophysics, they mark the definitive end. They are quintessential, merciless machines of destruction. People sense this intuitively. In our imagination, black holes symbolize the all-consuming nothingness, a border past which all life and all understanding stops, a glimpse into the hellish abyss, indeed. Black holes tell us of a world that is completely different from our own, a place where light moves not in straight lines, but in a circle. If I look ahead, I see my back. For one person, time seems almost to stand still, while for the other, it passes normally. Gas spins around at nearly the speed of light and can reach apocalyptic temperatures at which all matter is shattered into single particles. All that is left of molecules and atomic nuclei is a molten hot cloud of protons and electrons, plasma. I could fall into a black hole. I could also, in theory, survive and even conduct scientific measurements inside. But I would never be able to tell anyone what I see there. No information leaves a black hole, not even light waves. Black holes bring us closer to the beyond.
Thank you. This image reminded me in some ways of the Earthrise image from Apollo 8, that mission, and how that was the first time humanity was able to see Earth as a thing that exists in this black void, just sort of hanging there in all its fragility. And it really did change the way that I think that we saw the planet for a good long time. And a lot of people think that the environmental movement was related to that image. And I wondered if there was anything that's happened since the release of this image that you think it marks a shift in the way that people think about our place on this planet, but also in the broader cosmos, or just in general?
Yeah, well, it's only 2 years after that image, but I have the impression it has become iconic. Whenever you talk about a black hole, for sure that image shows up. But even if you talk about sort of the big questions of the universe, about the mysterious, the end of things, that image is being shown, and it tells us where the ultimate frontier is. We know about the Big Bang, which is sort of the I always say Big Bang and black holes, the alpha and omega of space-time. Big Bang is the beginning, this beginning singularity, and black holes, so to speak, the end of space and time. At the beginning, we can't really see. There's no image of the Big Bang, but we have now an image of the end of black holes. And I think it does make people think about it. And yeah, it maybe sound a bit arrogant to compare it to this Earthrise image, this blue, or the blue marble image of Earth from space. But it is a completely different and new world we're looking at for the very first time. We're looking really at the edge of our knowledge, and it's going to be a big battle of science whether we actually be able to overcome that ultimate frontier ever. So I think we are in an interesting time now where technology shows us everything. It gives us almost limitless possibilities. We can see black holes. We can do many, many things with technology. And yet that same technology tells us until here and not further for now. So, technology shows us our limits. And I think that's true in other areas as well, right? So we have, if you look at climate change and other areas that technology starts to, technology is beautiful. I love technology, but it also, it has the ability to destroy our planet. So it's this two-phased, it's two phases of technology. Show you new worlds, but also show you, in this case, where you may not be able to go.
Yeah.
Fundamentally.
Yeah, and like in some ways showing us back ourselves. I wonder how, when you saw the image, I'm sure you saw it as a person of complexities who is a scientist, a person of faith, and then just a human being. And I wondered how you who is a person of faith and you as a human being responded when you saw the image, and how you've been kind of integrating those selves around this image, and if the image itself has changed some of the ways that you think and feel and engage with your own faith.
Yeah, the way I describe it, and I think that captures it well, it was like a love story of 20 years where you have someone and you only write letters and you have an idea in your mind how that other person looks like, and then comes this moment where you see him or her for the very first time, right? And he or she is even more beautiful, at least at that moment, than you ever imagined. And that's the point when this dream, that fantasy, becomes reality. And that is such a wonderful moment, but also a moment where you were afraid a little bit. And so it was really this mix of everything. Well, it happened in stages. I saw, a first version, which was very promising. Then I saw an image. But I remember 1 hour actually where I had to go into my office, and for 1 hour I couldn't do anything else. I was literally hovering above the ground for half an hour. And there was a prayer going in, the silent prayer going out through this room, a prayer of thank you that I was allowed to see this. But also the realization that's not the end. I mean, and the scientist kicks in and says, be careful. That's exactly what you wanted to see. That's the most dangerous position a scientist can be in, right? And that's something that we told ourselves in this collaboration over and over again. This is so close to what we want to see. We have to be 2 or 3 times as critical to ourselves and test it. And you knew what it meant, and you didn't want to screw up, right? So if we would come with this image and it later would turn out to be wrong, yeah, it would have been a major blunder. And so you felt also this weight of responsibility, on our shoulders as a collaboration to get this right. And yeah, it was an interesting mix. To the outside, I tried to stay cool, but it was a very emotional moment, these first like hour or so. But then, the work kicks in and you have to go back to work and make sure it's, you do your job well.
Yeah, I can only imagine. It sounds, I mean, truly otherworldly, and then just like a spiritual uplift too, as well. You mentioned checking it and double checking it. How do you describe that to people without scientific backgrounds? Like, how did you make sure that this wasn't just what you wanted to see, but what actually was?
Well, science, sometimes people say science is not democracy. Actually, science actually is a democracy in the first place, because you have to convince other people. And in this collaboration, we work together, but we are also to some degree competitors. We are in groups from all around the world. And that's usually how science works. It's a competitive process where different people check things differently, and they look at the same data or take their own data, and then they compare, and then there's a discussion. And in the end, so the majority of your colleagues will say, yep, that's the right result. That's very convincing. The facts are just overwhelming. That's a scientific process in practice. And here we had the problem. We had only one world. We needed the entire world. We needed all the telescopes of the world. So we had to be our own referee, so to speak, our own competitors. And so we split up in individual groups. So we have our identities. There's Harvard, there is our university at Radboud, there's a Max Planck Institute. We keep Arizona. We keep our identity inside, and have our ambitions. And then there was competition inside the collaboration, and everything we did, and that's something we encouraged from the beginning. Everything we did at least 2 times. In the end, sometimes 4 or 5 times. We had 5 different softwares sometimes doing the same thing, but different people, different groups competing for each other and comparing each other. And they had to agree. And when they didn't agree, we had to find out why didn't they agree. And the first image we made by splitting up in 4 independent imaging teams, they were not allowed to talk to each other. They were just, doing that for themselves, and then we would reveal it to ourselves and compare the first 4 images that we made. So it's an interesting process. You have to build that into your own collaboration. We were just starting, so that was an interesting experience. It was in the end a successful experience, but it was also a traumatic experience. Let's be quite honest. It was an enormous amount of pressure, enormous amount of work, and competition is good, and sometimes that also goes wrong, right? So there was also conflict in the collaboration, and there's still, I had sleepless nights at times. So it was a pressure cooker.
Yeah, I mean, it is science, but it's also very human. And I think that there's a tendency to think that science is somehow like above human, but it's only ever practiced by humans. So practiced, I guess one would say, by humans. So inherently, it comes with all sorts of human elements as well. So that's fascinating what you say about competition and the trauma of having to make sure that it was right. But the whole process was designed to get something that was as true as possible to the information that you had collected. Yeah.
Yes, and there's always a point at some point where you have to make a judgment, and that is a human judgment. But I think we did everything as much as possible to really, what does the data tell us? And that's something you have to ask yourself all over and over again. And then, at the very end, you can be sometimes too careful, or you can be too outspoken. So that's an error you sometimes can make when it comes to interpretation. But I think I think we struck the right balance. I mean, I can say that because we looked at more data, we've redone the process and so forth. So I think the image is, we didn't screw up. I think I'm quite confident about that now.
Yeah, that's amazing. I mean, and it's such a long journey, and so many checks have gone into place. So I wonder, you've proven something magnificent can be done with this technique and through this kind of collaboration. What's next? Or what else are you looking at? And before you answer that, I just want to say I read a popular science article about the possibility of using this technique for maybe a visual telescope. Of course, it would. Those are very small wavelengths of light. Compared to radio waves. And so this is actually very theoretical. The storage of that data and then kind of combining it would require something on the order of like quantum storage because the wavelengths are so small. But I just wondered what you think about in terms of using this technique, or for instance, locating radio telescopes on the moon, or just what are we looking at going forward with this?
That technology is called interferometry. Is actually beautiful. You can build virtual telescopes of all kinds of sizes and in all kinds of complexities and for all kinds of purposes and localize things very precisely. I've used variants of this to at low radio frequencies to image lightning and cosmic particles zipping with the speed of light through our atmosphere, and you can adapt it to almost everything. So that's the beauty of radio interferometry, really. And you mentioned the moon. That in fact we're working on putting a radio telescope on the moon. We just won a study of ESA to put a radio telescope on the moon, but there we actually want to see towards the early phase of the universe, the dark ages, the Big Bang. That would be a low radio frequencies. But we could go into space with these dishes that we have. Maybe I'll switch just briefly to this is here this is in the background. See these are different. That's the world-sized telescope that we have with the different radio dishes we have, and the larger separation, the bigger the resolution. And if you go to space with some of these dishes, we'd have a super Earth telescope. And that's what we like to do eventually. We want to have more telescopes. I'm trying to get a telescope into Africa together with African partners. And then, in 20 years, 10, 20 years, we could go to space. And then we could really make razor-sharp images of black holes. I mean, it's just the first step. We can make movies of black holes. We can make, really detailed images of the structure around the event horizon. You can see how these plasma jets are shot out, how plasma is ripped apart, or plasma clouds, and test the theory of gravity, where it's, where it hurts the most, so to speak, because that's where you really put the theory of general relativity to the test near black holes and quantum gravity as well. So that's why I think we're really going into an age of space-time physics. That was like purely theoretical last 100 years. It's now an experimental science, and that really is a watershed moment. Will we find a new theory of space and time? That's a big question. We are looking for it, and we're hoping that the experiments, there are a few others, there are gravitational waves and other things, will lead, give us an idea. But it could be that this is out of reach for the next hundreds of years. So that's why it's it's such an interesting journey now.
Yeah, it does seem like it's just beginning, and it seems like this has been sort of the hallmark of your life is seeking to understand and to live in mystery, to be comfortable and uncomfortable in mystery, like acknowledging it and then but having a desire to like move through it in a way. And so, and I think, to me, that seems like something that like great scientists do, obviously, but also it's a hallmark of people of faith. And so I wondered about your childhood in terms of faith, to steal a question from the great interviewer, Krista Tippett. What was your spiritual life like growing up?
Well, I mean, I grew up in a traditional Protestant Christian environment. It probably most best to compare to like something like Presbyterian here in the US. And but it became at some point really very personal to me when I was young, and it when I had the impression that God is not just something. I never had the, I knew there's something like God, and it was like a distant and something, and but it was good because all your, you had a place, right? You knew all your questions would end somewhere, and in the end, they would end not in the nothingness. They would end in something called God. What is God? It was still something vague. It became very personal for me at some point. Like God is love, and God is someone that you get to know, that you can talk to, pray to, and expect something from. And so that really gave my life a new direction and hope. But it also led to many questions. So like I am in science, I was starting to read the Bible and talk with people, and I'm very inquisitive and discussing things. So I'm not someone who just if a pastor says, oh, that's what Jesus did and blah blah blah, then I say, yep, okay, that's how it is. I ask, what does it mean really? And it's so beautiful. I love reading the Bible and discussing with people in all these stories. Every time I read these stories, I discover something new, a new angle, a new question, also a new answer. And that's been the other part of my life. And as you said, I'm pretty sure I'll never know all the answers in this world and in this life. But I have the hope I'll, after my life, I'll be home. I don't have to answer all the questions now. I have absolutely fun to ask all these questions and answer as many questions as I can. But I'm not afraid of the open questions that will stay there, and the mysteries. I'm happy for them to remain mysteries.
I wonder if you can read from the last section of your book now, where you get into some of these bigger questions and really do such a beautiful job of tying everything together and making it so personal.
Yeah, so because of course, in me, the scientist and the in fact, I'm also preaching once in a while, as you may tell from the way I'm talking. And so those two personalities in me talk to each other, and what can you learn actually? And I think one important element in science, but also in faith, is skepticism and doubt, and that's something really underappreciated. We know it well in science, but even there, sometimes science tells us it's like becomes a godly authority, and in faith, you're not. I'm not talking about your doubts. But I think it's so important to keep them, to keep your doubts, and because we have to be truthful. So, that's one paragraph. But just as skepticism plays an important role in the advance of science, so is doubt an important element of my faith. The experimental growth for faith is life. The experimental ground for faith is life. And therefore, I must always subject my life and my faith to criticism. Maybe so many people have their doubts about the church today because some churches don't doubt themselves enough. The nature of the world and the nature of God will always be more complex than anything our limited reason can comprehend. Science without self-criticism is quackery. Religion without doubt, blasphemy. Politics without uncertainty is fraud. We can't know everything. And that's something that science tells us as well, and I think, and experience.
Yeah, that's such a powerful paragraph. Well, I think it's about time for us to open up to this Q&A. If you have any questions for Heino, please drop them into the Q&A. I'm going to be reading from some, let's see. Okay, this one's from Holly Lofgreen. She writes, I have enjoyed, hi Holly, by the way, she's a friend from Kansas. Hi. I have enjoyed your depictions here of the different senses and the visual depiction here of a black hole. You often hear of the spaghetti state as how the body would be infinitely pulled apart in the black hole. In my youth, I had heard they could never be photographically visualized. Since your faith is important to you, do you have an opinion on other dimensions as depicted in the movie Interstellar by Christopher Nolan, where the fourth dimension is love or where time has a spiritual element? If not, do you have a favorite Hollywood interpretation of black holes? Such a great question. I also had on my list Hollywood depictions of black holes and what you like.
This question begs for another book, actually. So the spaghettification, let's start with that one. That happens when you have a small black hole, stellar mass black holes, where hundreds of millions in our galaxy. But the supermassive one that we were looking at here on that image, that one is actually so big that you can fall in and you're not being torn into spaghettis. So that you can actually go into the black hole. And according to Einstein, you would not even feel anything when you go into the black hole. It's only the outside world will actually see you disappear, but you wouldn't even notice that really. So are there more dimensions? Well, boy or girl, whatever. Quantum physics or some string theories predict there are multiple dimensions. We certainly cannot picture them. I cannot picture them, but when I think about God and what's beyond the universe, yes, I do think there is sort of something that transcends space and time. Yeah, where all time happens at the same moment, so to speak, where space is all together. In fact, there's something happening inside black holes, both of these. But I don't want to take too much physics to visualize that, because I think it's really that's a dangerous route sometimes to go. But yeah, intuitively, I do think there is some bigger dimension, so to speak. Yeah.
Are you familiar with the Claire Denis film High Life? With
No.
Pattinson. The premise is basically a bunch of convicted criminals are sent to a black hole, and they are, providing experimental data on their journey. They're traveling very fast, some fraction of the speed of light, and it was fascinating to me. I mean, you might enjoy it because it's a different depiction of a black hole, once they get there, and of course it's a social experiment to have these people together and to endure the stresses of that journey. So that one was interesting too, and the ending to me seemed fairly ambiguous, which I sensed was correct for what happens in a black hole, based on what you've been talking about today and what I've read in your book, that there is something sort of like you never really know when you've crossed over that event horizon. And then once you're inside, there's a lot of it that is possible, that there's a lot of living that's possible, essentially. But what is that living? And you could never tell anyone about it. That's the kicker.
That's true. I mean, we can calculate a few things, what will happen in a black hole, but there's a range or part of the space that's not even calculable. So where we really don't know, which is also interesting. I talking about Hollywood movies, I would take some issues with the way it was depicted in Interstellar. I think it was done scientifically correct. The light was going around. They left out a few effects nonetheless, and the astrophysical models wasn't quite right. So I did cringe once in a while when I saw that movie. But it was overall it gives it's not wrong, right? I would have painted a slightly different picture. And certainly towards the end, the movie lost me a little bit. It got a bit too, yeah. It was a bit too creative, let's put it that way, at the very end. Despite my spiritual background, I thought it was a bit,
That's funny. Yeah. Do you have a favorite movie depiction of science or space travel?
Well, I have to admit it. I was a big fan of Star Wars and Star Trek, and there's always a big question. Which captain you like the most in Star Trek, and I'm a Picard guy, Captain Picard. He's such a moral character. It's just amazing. It's a moral superhero, so to speak. Like in a way you don't see it on movies anymore. Of course, it's surreal in a way, but that's what science fictions are. And and certainly I like this idea of exploring our galaxy and meeting different cultures and understanding them and talking with them and interfacing and so forth. So that remains an exciting thought.
Well, we have one last question. This is coming through the chat, and we touched on it a little bit. Where is your research taking you next? And so we know that.
Well, yeah. Sorry. We well, to be honest, this Galaxy M87 we published was just a lucky shot. We weren't quite sure we would, the black hole was that big. It was in the end. But there is the other black hole, the center of our Milky Way, called Sagittarius A star. And that was our real target. That's the one we wanted to see, because there we've measured the black hole mass extremely precisely. That's where we predicted the darkness. And that's what we still need to publish. So we're working on it right now. So stay tuned and let yourself be surprised, how the next black hole looks like. It's going to be much harder than the first one. That we knew. I was really surprised. M87 really surprised us. It made us easy. I was expecting us that we would have to work on this for years and years, and it worked on the first observing run. And this one is more difficult, but we'll be able to tell you what it will look like in a couple of months.
If you had unlimited resources to answer some astrophysical question, what would you spend those resources on?
Well, big telescopes is what we need. I mentioned the space telescope to look into black holes. This is certainly one. And the other aspect would be probably a giant optical telescope to complement this, because it's diversity also in astrophysics. We need to look at all the colors that the universe has for us. Only that gives us a comprehensive and complete picture. So I would build a giant radio telescope to look into black holes. I also built a giant optical telescope to look for other planets, other worlds, life on other planets. So I think that's what astrophysics is: exploring the unknown, the new worlds, black holes, planets, and they're still to be seen. The universe is big.
Really, it's very exciting to see to literally see what's going to show up in the next 5, 10, 15 years. I mean, it's just like, it's really just beginning. So thank you, Heino, so much for this conversation. And thank you for writing such a beautiful, thoughtful book and answering these questions. I wish you the best of luck in the future. And yeah, thanks again.
Thank you. Maybe we meet each other on Mars. So let's see.
That sounds perfect.
I thank you both so much and so kindly for joining us today. It's been such a treat hearing you talk. It's been a kind of a heartfelt journey listening to you two. I really appreciate both your research, Heino, and your questions, Kate. It's been quite the experience, and I'm very grateful that you could both be here today. And I'm really grateful to our audience who was able to join us and for your thoughtful questions as well. I would be remiss if I did not remind you that Heino's book is available for purchase at greenapplebooks.com or at your independent bookseller. We don't mind, we will share the wealth. But you should have it in your hands because it is a really beautiful book and you will appreciate it for yourself. It is an investment in your future. I will say too that Kate's book is coming out in paperback in 2 weeks, so keep an eye out for that. And with that being said, I will give you the last word and say good night now.
Good night.
Thanks so much, Gar.
Have a great day. Thank you.
Thank you.
Thanks, everyone.